here we have 5 coordinate pairs, and from these coordinate pairs we can try to make a mapping diagram. So this first value is the x coordinate and the second value is the y coordinate. The x coordinate represents the value in the domain and the y coordinate represents the value in the range. So we have the domain and we have the range. So let's try to see what values we have in the domain. So we have -4, we have -3, we have -3 here, so I don't need to write it twice. We have -2 and we have 6. Let's try to write down the values in the range. So we have -2, we have 2, we have 0, we have -3, and lastly we have -1. So I'm just writing them in ascending order. It's better to write in ascending order, but you can write in any order, it does not matter. Now we just need to map the values from the domain to the range. Now if you look at the input-output relationship, -4 is giving -2, so we just put an arrow towards -2. -3 is giving 2, so we put an arrow towards 2. -3 is also giving 0, so we just put another arrow towards 0. -2 is giving -3, so we put an arrow towards -3. And 6 is giving -1, so you put an arrow towards -1. So this is how we draw the mapping diagram for this problem. Now let's look at number 2. So let's make a box for domain and range. So for domain, we have -5, 5, 6, and 7, because 6 is repeated, so I don't need to write 6 twice. For range, we have so the lowest value here is -3. Then we have -2. We have 0. We have 1 and then 7. So we got all 5 values in the range. Now -5 is giving 0, so you just put an arrow towards 0. 5 is giving -3, so put an arrow towards -3. 6 is giving 7. And 6 is also giving -2. And lastly, 7 is giving 1. To determine whether this relation is a function or not, we just need to look at the values in the domain. So if any value is giving 2 outputs, it's not a function. So in this case, we can see that this -3 is giving 2 values, 0 and 2. So it's not a function. In number 2, you can see that this value is giving 2 outputs. 6 is giving -2 and 7. So it's also not a function. Okay, this problem statement says each table represents a relation. Represent the relation as a mapping diagram, then determine the domain and range and if the relation is a function. Earlier, we have seen how the relation was provided in a coordinate form. Now the relation is provided in a table form. So it's basically the same thing. We just have the input and the output in a column format. So let's try to make the mapping diagram. We have the domain and range. So in the domain, we have -1, 1, 2, 6, and 7. And in the range, we have -3, -2, 0, 5, and 6. So it's good to organize them in ascending order. Now -1 is giving 5, 1 is giving 0, 2 is giving 6, 6 is giving -3, and lastly 7 is giving -2. Now we'll determine the domain. In the domain, we can see that we have 5 values. So we just write the domain in discrete form. So in this case, the values are not continuous. We have 5 discrete values. So we just write -1, 1, 2, 6, and 7. So we just have 5 different values. And for the range, we also have 5 different values. We have -3, -2, 0, 5, and 6. Here the domain is given in discrete form because it only consists of certain numbers in the interval. So I cannot write it as -1 less than or equal to x less than or equal to 7, because it will include all the values between -1 and 7 inclusive. So I can have 6.5, 2.5, whatever you can take between -1 and 7. But in this case, we just have only 5 values for this domain. So we just write it separately. This kind of domain representation is called discrete domain. So we have a discrete value here, discrete domain. So that would be totally incorrect because this is continuous domain. Now to determine if this relation is a function or not, so first we identify the input values, which we already did. Then we identify the output values. We already have done the output values here. If each input value leads to only one output value, classify the relationship as a function. So you can see that from the domain, each value is giving only one output. So this relation is a function. Now let's look at number 2. For the second problem, again, we can see the discrete domain because each value is given separately. So in the domain, we have -6, -4, -1, 2, and 3. In the range, we have -7, -6, 0, 3, and lastly we have 4. So -6 is giving -6, -4 is giving 4, -1 is giving -7, 2 is giving 0, and 3 is giving 3. So the domain is we write all these values in this set: -6, -4, -1, 2, and 3 in the braces. For range, again, we put the braces here and we have -7, -6, 0, 3, and lastly 4. Now here we can see that each input value is giving us only one output value. So this one is also a function. Here we have another table and we need to find the domain and range. So let's quickly write down all the values in the domain. So inside the domain, we have 0. And you can see that 0 is repeated. So we just write 0 and then 2. Again, 2 is also repeated. And lastly, we have this 6. For the range, we have -7, 0, 2, 5, and lastly 7. So make sure that we write the values in ascending order to write in organized form. Now 0 is giving 7 and also 0. 2 is giving -7 and 5. And 6 is giving 2. To write the domain, we just write all the values that's present in the set. So here we have 0, 2, and 6. So make sure that we write these values inside the braces. And for range, we have -7, 0, 2, 5, and lastly 7. Now, to determine whether this relation is a function, we need to check whether each input value is giving exactly one output or more than one output. Here we can see that this 0 is giving 2 output values. This 2 is giving 2 output values. So this is not a function. Okay, this problem is saying each set of ordered pairs represents a relation. Represent the relation as a table, a graph, and a mapping diagram. Then determine the domain / range and if the relation is a function. So over here we can see that we have a set of ordered pairs given in coordinate form. We also have a graph given here. So let's try to represent this relation in a table form. So here we have X and Y column. For X we have, and for Y we have. So here you can see that input-output relationship in a table form. Now we can represent this relation on the graph. So on the graph we have -7, -3. So we just go to -7 on the x-axis right here. -7 is giving -3, so -3 is down right here. The second one is -7, 7. So we have -7 right here, and 7 we just go right here on the y-axis. The third value, -4, is giving 1, which is right here. The fourth value is 0, -6. So 0 is right at the origin. And then the y value is -6. So we go down right here. And then lastly, we have 1, -5. So 1 on the x-axis and the -5 right here. So this is how we represent the relation as a graph. Now we need to draw the mapping diagram. Now we can represent this relationship as a mapping diagram. So in the mapping diagram, we have the domain. And range. Now we have -7, -4. Since -7 is repeated, we don't need to write -7 twice. Then 0, then 1. For the y values, we can write in ascending order. So starting from -6, -5, -3, 1, and 7. Now -7 is giving -3. -7 is also giving 7. -4 is giving 1. 0 is giving -6. And 1 is giving -5. To determine the domain, we just write these values from the domain set. So we can see that we have a discrete set. So we just have -7, -4, 0, 1, and we write this within the braces. That's the domain. And for range, we just write -6, -5, -3, 1, and 7 within the braces. So we can see that -7 is giving 2 output values. So this relation is not a function because we cannot have 2 outputs from the same input. So we have seen how to convert these set of ordered pairs into the table, into the graph, and also the mapping diagram, and finally determine the domain and see if the relation is a function or not. Perfect. And there you have it. Keep practicing this topic with our practice question set. That's it for this video, and I'll see you in the next one. Now let's get to study.